There's one type of data operation you haven't seen yet, which is deleting data. If you're new to any version of EF Core, even the original Entity Framework, I'll warn you that this isn't intuitive at first. Most of us assume we can just say delete some ID, just like we can find an ID and execute it. And we could do that with raw SQL or stored procedures, which you'll see later in this course, and even a recently added method on the DB context. But if you consider how the context works, the standard delete workflow will hopefully make sense. The context needs to be tracking an object in order to send a command to the database when you call save changes, and it's the same for objects that you want to delete. That makes it possible to let the context know it needs to be deleted, and then you call save changes. And teaching you about deletes lets me finally get rid of that extra Julie Lerman in the authors table. I'll do that with the one that I just changed to Julia. But I also want to point out that this has an ID of 1, and looking at the raw data in the database, there are no books tied to that author record. We'll learn more about deleting related data further on in the course, but this gives me an easy example to start with. In my delete an author method, I'm first retrieving that author from the database using the find method because I know the ID. And even though we just looked at the database and I know that the record exists, I'm also doing a null check before moving ahead. If the result of the find is not null, not only do I have the author object, but the context is now tracking it. The method for deleting is not the word delete, as you might assume. It's remove. And remove aligns with other .NET methods for removing items from lists or collections. And it does make sense here. We're removing the object from the DB set, and it's up to save changes to turn that into delete from the database. So the code that I'm using now is context.authorsRemove. And just like the add method, you pass the object that you want removed as the method's parameter. When I hit that code in debug mode, I want to pause and show you the debug view so you can see that the context is immediately aware of the deleted state of the object. Just like calling the add and update methods, the remove method triggers the context to change the state. Next, my code calls save changes, and with this, EF Core sends a parameterized delete command using the value of the primary key as its only parameter, then sends the row count back to EF Core. And looking at the authors table in the database, that row for Julia Lerman is indeed gone. There are other ways to simplify deleting. For example, instead of querying for an object, you can just create an instance with only the key populated. Or you can use stored procedures or some custom code. And there's yet another path for handling deletes, which is referred to as soft deletes. It's a more advanced pattern, and therefore I won't be covering it in this course, but do look for a link in the resources at the end of this module for information about implementing soft deletes with EF Core. And starting with EF Core 7, we got a new feature called bulk updates. And that has a method called execute delete, which allows you to delete data without having to track it. You've seen a little bit of code where I'm working with multiple objects already. Let's look at some more features of EF Core targeted at this capability. So far, I've used the add method to add one object at a time to the context, and the update and remove methods as well take a single object. But you might have to add multiple items at a time. Imagine that the publishing company just bought another tiny publisher that only has 5 authors. And this is a really lucky publisher with some amazing writers. I could call add 5 times, but that's kind of a drag. Instead, I'll take advantage of the add range method, which allows me to pass in multiple objects. In this insert multiple authors method, I'm using add range and then on the fly creating an array of the 5 new authors. I'm unaware of an upper limit on add range. I'm just using 5 because that's sufficient for this demo. Note that this method exists only for convenience. It doesn't have any performance advantage or disadvantage over just using the add method repeatedly. One convenience, though, is that you could pre-create the list of objects that are going to be passed in. So here's one way to do it where I'm just creating the list and pushing it into add range. But even more interesting is that you could pass a list of objects around in your code and then just push this list into add range directly, as I'm doing in this insert multiple authors passed in method. And do note that the delete and update methods also have a delete range and update range counterpart. You can also use the range methods directly on the DB context. In addition to the benefit of the DB context methods enabling you to write generic code, the DB context range method also allows you to pass in various types at once. So it doesn't have to be a list of authors. It can be a mix of types: authors, books, widgets, contacts, whatever. The context can discover what each type is and create the appropriate entity entry object. Okay, you're probably waiting for me to hit that Save Changes line. Let's do that and take a look at the sequel. This is different than what we saw when we were updating multiple objects. We don't have 5 different insert statements within this command. Instead, it's using a SQL Server merge command. Let's look at what follows. It's gathering up the parameter values in first and last name pairs, then calling insert first name and last name for each pairing. And the output clause is designed such that it will be able to return all of the new IDs. The Performance Optimizations blog post I've mentioned a few times has a really good explanation of why they're using merge. It's time to take a look at that bulk update and delete feature that I've mentioned a few times. These were introduced in EF Core 7 after users had been requesting them for quite some time. You've already seen that it's a bit unwieldy to delete data that isn't already being change tracked. If the change tracker is aware of it, then it's not a big deal. You call remove and Save Changes will send the appropriate delete command. But if the data's not yet in memory, then what? We have had the ability to rely on external ways, such as calling out to a stored procedure or orchestrating soft deletes. And for those of you who may not be familiar with that pattern, a soft delete means that you aren't really removing the row from the database, but just making sure it doesn't appear unless you're explicitly asking for it. But being able to ask EF Core to just take care of a delete now covers some great use cases. The simplest is if you happen to already have the idea of a row, but don't have the object in memory. And pay attention, the method may not work as you might guess. You don't just pass a value into the execute delete method. It's more like a link execution method, where you need to define a query first and then apply the execution method. Here's an example where I'm filtering on the authors DB set for authors with ID of 9. And then I'm appending execute delete. The API is using the term execute intentionally. The method will execute right away, and it doesn't engage with a change tracker at all. It simply sends the SQL to the database and returns the number of rows affected. Hate deleting my beloved authors, but there goes number 9. And here's the SQL. As expected, thanks to the fact that the value 9 was in a variable, the delete command was parameterized. Here's an example where I'm writing the query predicate to find everyone with the last name starting with H. Sorry about that, you H authors. By the way, there's an example of grabbing the return value, which in this case is 3. And the delete command sent to the database is not parameterized. But if I put the H in a variable, the command comes in parameterized as well. And the database doesn't care that there's no matching rows to delete. The method just executes and gets back its return value, which is 0. Execute update works similarly to execute delete in that it gets appended to a query defining which rows to update. However, it needs some more information. What should happen in the update? And that detail becomes the parameter of the execute update method. And there's a lot of flexibility in what update instructions you can provide. There are lots of examples in the docs, but I'll show you a few here. The parameter is a lambda expression of property setters on which you can call the setProperty method. Then, with another lambda, you specify the property to change, and finally the value to apply. And that value can be a simple expression or another lambda expression. For example, you can simply change the value of a property as I'm doing here. I'm saying find all of the books older than 10 years and change the price to $1.50. That seems like a reasonable thing to do. The generated SQL is pretty straightforward. An update command which uses parameters because I provided the new value as a variable. And here are the books data with the new prices. You can also change multiple properties in one go if you need to. Sometimes you need to make a reference to a property when providing the update logic. For example, here I want to replace all of the last names with a lowercase version of those last names. And yeah, that's pretty random logic. And this requires a lambda expression for the value. I'm again referencing the last name property and applying the toLower method on it. And again, here's some reasonable SQL for applying that change and showing the data with all of those lowercase last names. One last example, I definitely want to fix those last names. I started out using more intelligent methods to set the last names back to title case. One of them leveraged a text info object and the other the toUpper invariant method of string. But LINQ wasn't able to translate either of those, which I found out with exceptions at runtime. So I reverted to a more manual way of combining an uppercase version of the first letter and the rest of the string to lower. And again, reasonable SQL is generated, and all of the last names were converted back. Although that didn't work out too well for Ursula Le Guin, I'd probably need to use AI to automate the proper casing of that last name. So we'll just leave it for now. With all of these examples, the processing is similar to the execute delete method. You append the method to a query, and notice that the DB set itself is a query, so do be careful with that. Then it executes immediately and has absolutely no interaction with the change tracker. Then it returns the number of rows affected by the call. One bit of very important advice is that you should not use these two methods when the change tracker is involved with the same objects. If you use these methods to update or delete objects that are already being tracked, the change tracker will have no idea about it, and chaos may ensue in your application. Safe Changes provides an enormous amount of database expertise to developers in a way that allows us to stay focused on our development tasks. Not only did you learn about the tracking and saving workflow, but you also learn what the entity in Entity Framework Core really is and how it's just another object in your application until the DB context is aware of it. While my demo's focused on the SQL Server provider, all of the database providers work closely with EF Core to build the correct and most efficient commands. And with respect to performance, you learned that EF Core batches database operations to minimize the number of trips made to the database when you call save changes. EF Core wraps calls and transactions when needed, and one more advanced but interesting capability we didn't see is that it also uses optimistic concurrency to avoid conflicts. And another one of those benefits that Save Changes provides is that it makes sure that any database-generated values are efficiently returned from the database and updated in your entities. In the next module, we'll sidetrack from persisting and querying data and make some changes to our domain model so that you can learn how to use EF Core's Migrations API to keep the database schema in sync with those changes. Here are some resources for you that are relevant to this module. Some are just reminders that you've seen already, and others, like an article explaining SQL merge joins and another about soft deletes in EF Core, might be of further interest. I'm Julie Lerman, and thanks again for watching Entity Framework Core Fundamentals.